Hello! This video deals with setting up an NFS server. In the previous video, we saw granting authenticated access. In this video, we will first install NFS server. After that, we will configure shares. Next, we will install the Nfs Client software, and finally mount the share. NFS, or Network File System, was initially created by Sun Microsystems to allow clients to access remote file shares on Unix systems back in the 80s. NFS is trivial to set up and is typically rather fast, but it can introduce some interesting security issues if it is not done correctly. Let's see how we do it, using sudo apt-get install nfs kernel server. Now configure shares with etc exports. Now install the Nfs Client software using sudo apt-get install nfs common. Finally, mount the share using this command. Awesome! Now let's see how it works. The nice thing about NFS is how trivial it is to set up. You simply install the NFS server, configure etc, exports, and go. The only real details to learn and understand are some of the options available and their implications. Path to share. This is the absolute path to the directory on the server, which you want to export. For ease of maintenance, it is recommended that you add a level of indirection using symlinks to repoint the path. Client definition. This is how we define what systems may mount the share. You can define it via an IP address, hostname, or a NIS netgroup. If you are using NIS on your network, host names or IP addresses may be specified with a wildcard if desired, or you can specify IP addresses by CIDR block or with a net block. Note that host name lookups are done via reverse DNS records, so you must have them set up properly in order for it to work. Finally, options, of which there are a lot available. Here are a few major ones to keep in mind. RORW. This determines if the share will be read-only or read-write. Shares are read-only by default unless RW is added as an option. Sync async. NFS shares are synchronous by default, meaning that when a write operation is performed on a file, the NFS server will not reply to the client until that write has been written to the disk. This behavior ensures a more consistent state in the event of a server crash, but has performance implications, especially on slow media. You may use the async option in order to make writes asynchronous instead. Root_squash, no_root_squash. Root squash is a security control that tells the server to map requests from the root user to the nobody user in order to prevent a malicious client from being able to perform actions on the server with super user privileges. It is the default behavior, but it can be overridden with no_root_squash. The client side also has a number of mount options available, which can be specified with A to O to the mount command, or an option specified in etc fs tab. The client has even more options available than the server, but we will just look at some of the common ones again. Hard, soft. Hard versus soft mounts determine what should happen in the event that your connection to the NFS server is lost. Soft mounts will report an error in that case, while a hard mount will instead block until the file server returns. Knows UID. Don't allow set UID binaries on NFS. TCP, UDP. Access the NFS server over the TCP or UDP. TCP has a small performance hit in certain use cases due to the overhead of the TCP protocol, but it performs better on heavily congested networks. In the event that the connection to the server is dropped due to a connection problem, TCP will revert to attempting to establish a connection, issuing SYN requests with a backoff, while a UDP mount will continue to attempt to send data to the server since it does not know the connection is dead. Let's see what is more to it. Unlike many other file services, most NFS servers do not provide any sort of strong authentication authorization. Instead, NFS exposes standard Unix file permissions and file ownership via UIDs. The client system is responsible for enforcing access control at that point. This means that it is possible for a malicious client to access any files or directories it would like to, regardless of file ownership. The biggest examples of this problem are the UID collisions. Let us say that you have a file server that contains home, Alice, which is owned by Alice's account, with UID 1000. Home is exported via NFS and made available to other client systems on the network. Now let's say that Bob owns a desktop machine which uses UID 1000 for his user account as well. If Bob mounts home from the NFS share, Alice and all of its contents are owned by Bob and will grant access to all of the files. A common solution to the conclusion problem is to have all client systems of the NFS share a centralized directory service, such as NIS or LDAP. This will protect you against accidental collisions from trusted client systems, but not from malicious systems. The newer solution that should protect against malicious clients as well is the use of Kerberized NFS. This refers to protecting your NFS share with a Kerberos system, such as MIT's Kerberos 5 implementation, or a system like Active Directory. Fantastic! In this video, we saw how to set up an NFS server. In our next video, we'll look at configuring WebDAV through Apache.